All right, class, welcome to 5.1E lesson, scientific notation. Uh, an exciting lesson because it allows us to abbreviate large numbers, and it's rather useful when you use very large numbers or very small numbers. So let's just dive right in. Most of us would agree that texting is a fast and efficient way of communicating. In fact, texting allows us to abbreviate many common phrases. Mathematicians and scientists have a way of expressing really large and really small numbers in a fast and efficient way. It is called scientific notation. Just like texting allows you to communicate quickly, scientific notation allows you to write very small and very large numbers more efficiently. Okay, so how do we do that, right? Write the four expressions below in standard form, and what do you notice? Okay, so in the past class, you've understood that multiplying by 10 will, move the decimal place one placeholder, and for that reason, dividing by 10 would also move the decimal one placeholder to the other way, to the left side, right? So really, when I see something like 10 to the negative 1, it's telling me to move the decimal from 500,000 back one placeholder, okay? This is making it smaller, right? 10 to the negative 1 power is technically 1/10, and then obviously 10 to the 1 power is 10, right? So any positive number makes my value larger, any positive exponent, I should say, and then any negative exponent is really just dividing by that amount of 10, right? How many times do I have to move the placeholder is really what the exponent is telling me to do. So 500,000 times 10 to the negative 1 is going to be, instead of 500,000, it's 50,000, right? 5,000 times 10, well, that's going to be 50,000 again. Oh, that's nice. And 5 times 10 to the fourth, well, that's like saying 5, move the placeholder 5.0, but move the placeholder 1, 2, 3, 4 units to the right. And that gives me 50,000 one more time. And then finally, zero point 0.5 times 10 to the fifth. Well, you could see that that's one more placeholder than the 5. And that's going to give me 5, 1, 2, 3, 4 placeholders. And that's going to give me 50,000. So all four of these are equivalent to the same exact value. Now, before I even say the answer, which one of you or which one of these do you think is properly written in scientific notation, right? Oh, wait a minute. It literally says that in the next sentence, right? In the above problem, only the expression 5 times 10 to the fourth is written in scientific notation. Any number in scientific notation must be written in what form? What can you say? Why do you think C is the only one in scientific notation, right? Explain why the other three expressions are not written correctly. So here's the definition of scientific notation, class. In order for a number to be written in scientific notation, the value of the first significant figure must be greater or equal to 1 and less than 0. I mean, less than 10. I'm sorry. So we basically want you to give me one significant number. Uh, in this case, it's just a whole number 5, but we want at least one digit to the left of your decimal, and it has to be significant. So if you see zero point 0.5, you can see that there is a digit to the left of the decimal, but we want it to be the one that we care about, not just a zero. The zero in this case is what we call a placeholder. We want to know a significant number, which is the 5. Okay, so with time, you this will make more sense. But let's just say, let's talk about Mr. Quo's bank account, right? Let's say, example, Mr. Quo has $72,000 in his bank account. That could be right. That could be wrong. That could be the dream. That could be a nightmare. Who knows? Right. But let's just say that that's in my bank account. Okay. This is obviously not in scientific notation. The decimal is right here. Right. So what we want to do is we want to put the decimal in front of the first significant number. Right. So, what do you think is more significant in my 72,000? Is the 7 the most significant, or is the 2 the most significant, right? So, I hope you realize that the 7 is the most significant because it's in the 10,000s digit place, right? This is 10,000. This is the most important number because it's the furthest from the current decimal on the left. So what I'm going to need to do is I'm going to need to move the decimal 1, 2, 3, 4 places all the way into the front of the 7. So I get 7.2, right? 7.2 is how I would write my like first term. And then you write a dot that represents multiply. And then you ask yourself, how many times did I switch from my current decimal to where I placed it, right? I gave it 1, 2, 3, 4 placeholders backwards. Okay. I reduced it by 4 placeholders. And that's technically 10 to the negative 4, right? However, do you think that if this is my bank account, or this is your bank account, or this is your friend's bank account, do you think they would be happy that you took away 4 placeholders like that? Like, sir or ma'am, your bank only has 7.2. And you'd be like, that's not right. I have 72,000. So instead, what we did is we took away 4 placeholders. So you have to give it right back and give it 4 positive placeholders. And that's how you write something in scientific notation, right? So in conclusion, you have to place the decimal in front of the first significant number, leave it there. You write the remaining digits that are not zero, obviously. You don't need to write zero. And then you see how many times you moved backwards or forwards. Eventually, we will go forward. But if you move backwards, you have to provide the digits back to the original number. 7.2 times 10 to the fourth is equivalent, right? 7.2 times 10 to the fourth is equivalent to 72,000. Okay. That was my example with scientific notation. Okay. So let's now practice by completing the table. Okay. 6.345 times 10 to the eighth. Now, what I like to do is I see that I have to use 3 placeholders just to make this 6345. And then I have 5 more zeros to go in terms of my 10 to the 8, right? If I use 3, I still have 5 more to go. So this is 6, 3, 4, 5. 1, 2, 3, 4, 5. That's a big number, right? That's really the point of scientific notation. When we take really, really large numbers and we're able to kind of reduce them to a smaller looking phrase, if you want to call it that, right? I use 2 placeholders for my 8.04, and then I have 2 more zeros to go. So this is 84,000. That's 80,400. Okay. 4.26, 2 placeholders, 3 more zeros to go. 426, 1, 2, 3. That's 426,000. Okay. Now, this is expanding, right? When the exponent is positive, you're expanding the number. You're making it larger. However, when your exponent is negative, you're not going to the right anymore. You're going the opposite direction. You're making the number smaller. So 10 to the negative 3 means that I have to move 3 more placeholders backwards. And you can see that that makes this number smaller, right? When we're dealing with something in science or a chemical or some sort of DNA research and you're looking at very, very small particles, you would say that that's something with a very, very, a negative exponent, right? Okay. So 10 to the negative 8. Notice how I move one placeholder just to get it back to the edge. And I have 7 more placeholders to go. So really, I know that it's point 1, 2, 3, 4, 5, 6, 7, and then 42. Have to be careful here, right? And then double check. Do I have 7 zeros? And then do I have the 4? That gives me 8. Here, 8.12 times 10 to the negative 7. That means I need 6 zeros. 1, 2, 3, 4, 5, 6, 8, 1, 2. Okay. So we practice converting something in scientific notation to standard notation. Now we're going to take something in standard notation and convert it to scientific notation. Okay. So here, if you just follow along, I hope this will be easy for you. And always take a look at your pen and say, hey, my decimal is currently right there, right? I need to move it in front of the first significant number, the 5. So I'm going to move it 3 units to the left. And the number is not going to like that. The number is going to say, hey, I was 5,000 and you made me 5, right? If your feelings would be hurt if you were the number, right? So you're like, hey, I was 5,320 and now you made me 5.32. But you say, hey, number, don't worry. I'm going to give you back 3 placeholders. I took away 3 placeholders by going backwards. I'll give it right back to you right here. This is the part where this will make the number feel good again. The number, if you multiply this, it will go back to this, right? So let's do that one more time. 420,000. Let's move it 1, 2, 3, 4, 5 times backwards. 5 times backwards is -5 movement. But don't worry, because I'm going to give it right back with the 10 to the 5th, right? So scientific notation always ends with a 10 to some sort of degree, okay? Now again, this is, this is 9 billion, right? Mr. Kuo's checking account, the accurate checking account value, 9 billion. Let's go and add 1, 2, 3. We're moving 3 units, 6 units, 9 units backwards, right? We're going in front of the first significant number, which is obviously the billions. So then I write 9.04. Please don't forget to write the 04, right? You might think that that's barely anything, but in this case, that's 40 million that you can't ignore, right? So 9.04 times 10 to the 9 is going to be our scientific notation. Okay. Now, obviously, we were taking really, really large numbers and we were making them smaller, uh, decimals, and we then gave back the degree, right? The reverse is also true. You can make small, very, very small numbers large, but you better kind of take away the digits. Okay, so let's look at this one. We want to put it in front of the 5. The 5 is the most significant number. You could think of the most significant number as the the number that indicates what the overall value of that number is, the largest number possible. Usually it's to the left, right? The number furthest to the left is, other than the 0, is the most significant. So here I'm going to go from the decimal and I'm going to move 1, 2, 3, 4, 5, 6. And I moved the decimal 6 placeholders, and I made the 0.000054. I made it 5.4. And the 5.4 is really, really happy all of a sudden. It's like, hey, I can breathe again. I'm a full 5.4 now. And you're like, don't get too excited because I'm going to take away 6 placeholders. You didn't get 6 placeholders for free. I'm going to take it away. So you push it back. And if you were to do that and push it back 6 placeholders, you would get back to your original, right? So let's do this one. 1, 2, 3, 4. You move 4 placeholders, you get 7.5, and then you get times 10. Because I moved 4 placeholders forward, you have to take it away when you do the 10 to the negative 4, right? You can't just move the placeholders for fun and not expect to kind of negate it and take it away later, right? That's what math is all about. If you do something to one number, you have to either do the reverse to it so it can stay the same, or you have to do the same thing to the other side of the equation. It's one or the other, right? Here, 1, 2, 3. Right when I get to that 4, I've already made it to the significant number. So I don't have to move it all the way to the 5 because the 4 is the most significant number. And I moved 3 spots to get to 4.005. So if I move 3 spots to get there, I better take away 3 spots as well. Okay, this table was pretty much the entire lesson. If you understand how to convert from scientific notation to standard notation, that's great. Obviously, that's a skill you need to know. But you also need to know how to take something in standard notation and then convert it to scientific. Okay, so in scientific notation, if the exponent is positive, the decimal is moved to the right. Okay, and to convert to standard form. In scientific notation, if the exponent is negative, the decimal must move to the left to convert to standard form. Okay, so like for example, 2 times 10 to the third, you have to move the decimal 3 units to the right of the current placement of the decimal. So 2 times 10 to the third is 2, 1, 2, 3, which is 2000. Right. Whereas if I had 5.3 times 10 to the negative 4, this 10 to the negative 4 is telling you to move your decimal 4 spots to the left, which gives you 0.00053. Okay. Only were able to do one page in this video, but there was so much information in here that I think it's time to take a break. Let's take a break. And when we come back, we'll have part 2.